Hello, welcome back to Learn Economy. Having discussed the meaning of autocorrelation, in this video we are going to see the causes of autocorrelation. You could understand, we have already understood that autocorrelation involves serial correlation, right? So this is seen in the time series data. That is, your present value is it is something which depends upon your previous value or past value. So this is what autocorrelation is, to give you a very vague idea. So, having understood that, let's understand the causes of autocollision. The first and important cause is inertia. So, when I say the first and important cause is inertia, this means that inertia plays a very important role in causing autocollision. What does inertia mean? It is sluggishness in time series. So, if you're taking the examples of gross national product, production, price index, employment indices, unemployment data, etc., you can see that these exhibit business cycles. If you look into the case of economic fluctuations, you can see that starting at the bottom of recession, the economic recovery starts, right? So that means that if you're comparing the recession period and the recovery phase, then you can see that the bottom period of recession is actually something which influences the recovery period. So that, or in other words, you could see that in the recovery period, in the initial phase of recovery, it is something which is very much dependent upon the last phase of recession. So most of this time series start moving upward in the case of what, a recovery, but this is only after the last phase of recession. In the upswing, what happens is that the value of a series at one point in time is greater than its previous value. So these successive observations are actually likely to be very much interdependent. So in this case, you can see that inertia gives rise to what is known as autocorrelation. Next, we have omitted variables specification bias. In your model, if you are actually not including one of the important variables that influence your dependent variable, you are not taking that independent variable in your model, then that means that this particular important variable which you have omitted is actually captured by the residual or the error term. That means that the residuals may suggest that some variables that were originally the candidate but not included in the model should be included. So this is not a specification bias, or you have excluded one of the important variables and you have run a wrong model. You have run a wrong model means you have run a model. Uh, you have run a model by omitting one of the important variables. Okay, so the inclusion of such variables actually can remove the correlation pattern, and also it can improve the residuals, and actually it can do away with the problem of autocorrelation. Next, we have problem with respect to incorrect functional form. If you are building a model, you have to give correct specification of the variables or the model. Suppose your yt, which is your dependent variable, is connected with x2t, that is one of your independent variables. So this connection is with a quadratic relation. But if you write the model wrongly, you will be getting a linear relationship. Actually, you are actually not trying to understand a quadratic relationship. That quadratic relation is not captured by your model. Your model will give you a wrong result. In this case, the error term obtained will give you a straight line specification, but the correct UT is not depicted by your model. Your model will depict a wrong UT. Okay. So in this case, you have to give a correct functional form to eliminate the process of eliminate the problem of specification bias, to do away with the problem of autocorrelation. Next, we have a Cobweb phenomenon, and this is considered to be one of the causes for autocorrelation. For example, the quantity supplied in one period of many agriculture commodities depends on the price in the previous period. So this is Cobweb phenomena, And why does it happen? This is mainly because the decision to plant a crop in period T or today, or just take today as period T. So the decision whether to plant the crop or not taken by the farmer, it is something which depends upon the price of that particular the price of the yield in the previous period. If and only if the farmer sees that he would be gaining profit in the future, he will be planting a certain crop that will give him some return. If the farmer foresees that he will be getting a loss in the future, then by planting certain crops, then he will just avoid planting those crops in the future. However, you can see that the actual supply of the commodity is available in the period T plus 1. That means that all these are connected. All these are actually beats of a particular chain. Next, you have a lag relationship. The effect of the same will also lead to autocorrelation, especially in the case of business and economic research. You can see the influence of lag values of the dependent variable which you use as explanatory variables in your model. You take the case of taste and habits on consumption. I mean the influence of taste and habits on consumption in a particular period. You can see that consumption in one period is used as an explanatory variable, since consumption do not change, especially when this has become a habit for the consumer, for psychological reasons, technological reasons, institutional reasons, etc. So that's it. Then there can be data manipulation causing autocorrelation. That means that if you're taking an example in a time series regression involving quarterly data, such data is actually derived from monthly data, right? So this is by simply adding some 3 monthly observation and dividing the sum by 3. This is how quarterly data is derived, and this averaging introduces smoothness into the data by dampening the fluctuations on monthly data, and this smoothness will lead to a systematic kind of pattern in the disturbances, and as a result there will be autocorrelation in your error term. So that's all for the causes of autocorrelation. I could sense that you could get some idea with respect to what autocorrelation is, its meaning, its causes, etc. in this video. I'll be doing a video on consequences of autocorrelation as well, and also we'll be doing some videos on the tests which could be used to deal with the problem of autocorrelation. Anyway, if you are running a model, you have to, especially if you are doing time series models, you have to make sure that your model is free from autocorrelation. So in order to see whether your model is actually has a problem of autocorrelation or not, you have to go through certain tests, you have to conduct certain tests. So we will be doing all these things in the coming videos. Till then, you can be a part of my Telegram group and Telegram channel. You can even after that you can be a part of my Telegram group and Telegram channel. I'll be providing the links of the same in the description box so that you can take it up. So please like, share and subscribe, and please do come and join in my Telegram group and Telegram channel to discuss your doubts. That's all for today. Thank you.